All right. So, my intent is to give you some questions today, just general practice. I want to do this for a little while because I'd like to give you a quiz. Okay. It would be on all sorts of different integration techniques. Okay. Basically, all the stuff that we've covered up till now. Um, and I'm not trying to go crazy and pull really ridiculous problems out. I think that I'll basically be giving like exemplar problems, but it'll be a mixed bag. You know, some will be U sub, some will be parts, some will be partial fractions, some will be trig, some will be inverse trig. But you know, consider a big mixed bag of integrals. And that's why I wanted to spend 2 days of review so that we can test next week. So is anybody looking at their calendar and sees a problem with September 30th? You know, you got 5 other tests on that day or something, or would it, you know, anything like that?
What day?
1 week from today. Hearing no objection, we will have the test next Wednesday. The test, it would be on all techniques of integration. So we've got U sub, we have parts, we have trig, inverse trig, partial fractions. What else have we done? That's a lot of it.
Unit square.
Yeah, that's part of trig. I mean, it's a technique that you need to know how to do. What else? I don't think that's it. All right, that's plenty. Now remember, with parts, you've got, you know, you can do, you know, regular parts, you know, and then there's ones with the table. And then there's ones that double cycle, and that's the one where you use the I. Remember, I equals the integral, and then you bring it over to the other side. Remember those? You'll have your formula sheets, so you know your trig substitutions will be there. What else? That's enough. Okay. The way I'm going to do it is you guys just take pictures of your stuff. I'll email you the test at the beginning of the period, and you show me all your work, take pictures of everything, and then send it to me. Okay? All right. And then I start hating life because all of my classes are taking a test on that day. Everyone, yay. Thank you, Ben. I appreciate your generosity. We don't have to have a test that day, but I want to give you one. You know, so there we go. It's a gift. I'm giving you a test. You should be thankful.
Thank you.
Oh yes. Oh yes. You get to measure yourselves and see how good we are. Absolutely. All right. So we can't use U sub, can we?
Oh, because you need a sin x.
Yeah, we don't have a sin x anywhere. But we can turn this, there is a trig identity that you need to know for this. Remember, there's three of them. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And from our Pythagorean identity, we get 2 more. And it's these two that we really care about. Because if we solve for sine squared or cosine squared, then what you get doesn't have any squared terms in it. So in this case, we're going with cosine of 3x. So solving this for cosine squared, we get 1 plus cosine 3x all over 2 is equal to cosine squared 3x. You need to know these two identities, ladies and gentlemen. Okay, I don't think they may be in your formula sheet. I don't know.
Wouldn't it be cosine of 6x?
Yeah, why do you always get it right? Finger gesture. And now you can do your substitution, and now you can solve it. Be my guest. How did that go? Ty's sitting there like, what am I doing in this class? It's like, what was I thinking 2 years ago? All right, are we good with this one? Question, Maria, what's up?
How did you get pi plus 0? Is that what the sine of 6 pi over 6 turns into?
For this stuff over here?
No, for the first part of that equation.
This one?
Yeah.
So yeah, I just plugged in pi.
Mm-hmm.
So, the integral of 1 is x, the integral of cosine is sine.
Yeah.
And I got to deal with the 6, so I get a 1/6. And now I plug pi into both places. And so pi plus sine of 6 pi over 6. Now 6 pi is basically just going around the circle once, twice, and then 3 times. So it's still the sine of 0, and the sine of 0 is 0.
Okay, that makes more sense.
Yeah.
Thank you.
Sure. Okay. Da-da-da-da-da-da-da-da. Enjoy. How did we do on that one? Steven, you look thrilled and excited over there, man. You all right? All right. Had that.
Mr. Ronco,
Speak to me.
so after you do 1 over u du,
Yeah.
why doesn't the natural log stay under the 1?
Here.
Yeah, so 1 over u, and then the next step.
Okay, so my 1 over x,
Oh, wait, no, sorry, I get it now.
yeah, that's my u.
Yeah,
That's my
okay, yeah.
du, yeah.
Yeah, sorry, yeah,
You're
my
good.
bad.
You're good. Okay. Oh lordy, lordy, lordy. Let's see how sneaky y'all are. Find this exactly. Your answer should be a natural log of a small fraction.
Are you sure you split that polynomial correct? 'Cause I think if you, the way you have it written, if you expand it, it's a pop. Oh, I wrote the problem down wrong. That would be why.
That happens.
I do that a lot. Don't worry about it.
It happens all the time. That's the first thing you should check. Happens to me all the time. That's right, Ridvik. Keep it muted, buddy.
Since it's a definite integral and the numbers inside the natural log are positive, do you have to still keep the absolute value signs?
Wait,
Not necessarily. You don't need it. It's habit for me.
how did you just suddenly get to that?
Magic, dude. Mathemagic.
Oh, great. Oh, you can. Oh, so everything that's negative goes. Oh, okay. I get it.
Yeah, all your negatives go down below, all your positives go up top.
And yeah, I forgot that coefficients square what's on the inside. Well, like, you know what I mean?
Yeah. So like your 2 natural log of 4 becomes natural log of 4 squared, and then 36.
Could you explain how to, or your thought process after, or like starting when you put in 7 and 5 into the equation?
Okay, so you're cool with this to this, or is this the step you need? You need this step, or do you need that step?
I think the first one. Also, I got the negative natural log of the absolute value of x minus 1 plus 2 times the natural log of the absolute value of x plus 2. Is that going to change my answer somehow?
Yeah, if you basically, I think what you've done is you've put the 2 on top of this one and this one on top of that one.
Yeah.
Okay, if you look carefully at your piece here, and I'm just going to walk through that real fast. I'll just write it down one more time. So what I've got is I've got x plus 5 all over x plus 2, x minus 1 is a all over x plus 2, and b all over x minus 1. And so cross multiply, not really cross multiply, but common denominators gives you that is equal to x plus 5. And then from here, you distribute.
I got all that. Oh, I see what I did. I think I,
It was here, I think, maybe. Or you put them back on top of the wrong things.
I think I did, yeah.
Yeah, that'll do it. And now, so I've got the straight up reciprocals. Those are my natural logs. I don't have any coefficients to worry about except for the 1 and the 2. And then when I plug in 7 and 5, I get 9 and 6 and 5 and 4. I distribute my negative. That's where the red comes from. And now I just put all my negatives in one place because I've got this guy as a negative, and the 2 comes up as an exponent, so it becomes a 16. And the 2 comes up as an exponent, it becomes a 36. This is positive 2. So both my positives are here, both my negatives are here. My positives go up and my negatives come down. And then 36 is 9 times 4, which reduces the 16 to a 4. And I'm left with 7/4.
Where does the 2 in 2 natural log of 6 come from?
There.
I meant for the,
This one?
Mhm.
That one's this one.
So it moves, I guess?
Doesn't. No. It's 2 natural log of stuff. And
Mhm.
so when I plug in the 7, I get 2 natural log of 6. And then this exponent, this coefficient comes up as an exponent and becomes my 36. And then the same thing happens over here with this 2 is this 2, and then it comes up and becomes 16.
Okay.
Cool. Just a second, ladies and gentlemen. Okay. Okay, you can do this in one of two ways easily. Who did what? Ty, what'd you do?
I tried to do the partial fractions, but it didn't really.
Yeah, in order to do partial fractions, the denominator has to be a bigger coefficient, bigger exponent than the numerator does. If they're not, then you have to do long division first, which you can do. You can do long division on that,
How did that?
and
How
it
does
works
that
out.
go?
Connor, what'd you do?
I tried to split it up into two different integrals. which
Okay, how'd
kinda
that go?
worked. It worked all right, but I kind of got stuck towards the end.
So
I
you
don't
did
know
something
if
like that?
yeah, that's what I had.
Okay, now the one on the right is easy. That's just a natural log.
Right,
This one over here, you got to do a u sub with,
right, okay.
and then change the variable, which turns into this. And then once you've done with that integral, that just becomes 1 and 2 over u. And then integrating that with respect to u, you get that. Now, u is just x plus 2, so these are like terms. So I just combine them and resubstitute u and get this. Did anybody get that, whether this method or another?
I tried trig and that did not work.
Trig's no fun for this, although it's possible.
Synthetic division made it real easy.
Yeah. Another way that's probably the most straightforward is just do a u sub.
Could you just do the u sub for x plus 1 and
Sure,
then
you could do that too.
separate it into plus 1 and plus 1?
You could do it either way,
All right.
but you're still going to have to do a change of variable. You got to get x alone, even if you did it with x minus as x plus 1, x plus 1. So if you wanted to do it with the numerator instead of the denominator, then you could. It'll work, as long as you don't break algebra rules. So it was x plus 1 all over x plus 2. Is that right? Yeah. Let u dx. U is equal to x plus 1. X is equal to u minus 1. So now we wind up with the integral of u all over u plus 1 du. And you see at this point, we need another tool here in order to integrate that. You see, because we can't do a u sub on that, and that's not an integrable form. You see, we run into that small little bit of a problem. You could do another u sub and then another change of variable, but it's basically going to bring you back here. If you said v is equal to u minus 1, so u is equal to v plus 1, now I've got v plus 1 all over v plus plus 2. And we see we're back to where we started. See, it kind of is It doesn't help you. The reason why why it's better to use a u sub for your denominator is that if you do the u sub with your denominator, you wind up with this, and this breaks apart. You see, I can't do that. I can't break that up, but I can break that up.
You could like I did it with like synthetic division, then I had the remainder.
Yes, you will. Yes, you would have to do synthetic division and then get a remainder. Absolutely, you could do that for sure.
All right.
And then it would work. That's another option. Absolutely. Okay.
Wouldn't x be equal to 2u plus 1? I mean plus 2.
Yeah, plus 2.
Yeah, I did the order of operations wrong. It's going to change me a little bit.
I just had a 8
No, I
instead
can
of
do it. I can do it. No, that's right.
Hey, Mr. Rocco, could you go through how you did this?
So
Wait, and then wouldn't there be a 2 outside the integral
Yeah.
because the 1/2 dx?
I'm not worried about that now. When we get to it, we'll get to it. I'm going to go through the problem. I'm not playing a fishing game right now. Okay, so my u is actually, this should have stayed a 1. That's my u. I take a derivative, and that's my dx. So I'm missing a 1/2, and that's why I think you were going. So I just need a 2. Make that times 2. All right, we'll do the whole thing over again. Too many errors on one page. Oh. So u, 2u plus 2 is x. Du is equal to 1/2 dx. And x is my 2u plus 2.
How did you get that x equals 2u plus 2?
Solve for x.
Okay, yep.
So for 2 minus 1. And that becomes 3/2. And I need a coefficient of 2/3 plus x squared minus 1 to the 1/2. And I need a coefficient of 2. And now I simplify. And if you really wanted to, you could go a little further. and stuff like that. But no one really cares about going this far. See what I mean? There's lots of crazy algebra you can do. But on the test, just get me here. But realize that you've got a common factor of square root. So you pull that out and you've got nice happy constants, variables, distributing, simplifying, and then pulling out another GCD. And getting a common denominator, and then pulling that radical out, just reducing 8 to just become 4 square roots of 2. But anyway, no one cares. Next. Okay, let's pick something evil.
That means we can use a calculator.
Mm-hmm.
Mr. Ronco, can you show it one more time? I had bad handwriting that time. Thank you.
Sure. you get an answer, go ahead and type it in the private chat.
How many sig figs did you say?
3. Okay. Andrew, you got an answer?
No.
So if you didn't get it, do you see where you goofed it? Okay. We cool on this one? Do we see what we did? Okay. This is part A. Yes, Ryan, it involves factoring. And if you've simplified that,
What's the problem again?
so we are just about out of time, if you can believe it. So hopefully that makes sense. this way. So who got that?
See, what I was thinking difference of squares, but the negative and the exponent threw me off.
It's still squared. Because remember,
Neg
exponent to an exponent is multiplication. A power to a
Oh.
power. And these two cancel, which gives me this guy. And he's just a U sub. All right. All right, here's what I'm going to do. Just so that we have something to practice, I'm not going to take this as a homework. I'll just consider this as let's do this. I don't know. Can I put? I guess I can't do that. Okay, we're going to try and see if I can do this or not. I can't. All right, so here's what I'm going to do. Somebody, all right. Who's got the group chat? Everyone? Um, all right, I'm not sending this to the whole universe. I'm just going to send it to 5 of you, and everyone else is going to send it around. All right, so I have sent a photograph, or not a photograph, a screenshot to Maria, Ritvik, Christine, Andrew, and Dylan. And I'm hoping that one of the 5 of you will forward it on to everyone else.
Can you try putting the screenshot in the Zoom chat?
I don't think I've enabled images to be allowed.
Oh, okay.
Yeah, because that's how people cheat.
Oh.
That's one of the ways people cheat. Okay. Has anyone gotten it in their inbox? Dylan got it.
I got it.
Maria got it. Ritvik. Okay, somebody, one of you guys, please forward it onto the group chat. Lauren, are you on the group chat yet? Yeah, okay. Beautiful. All right, so you can leave once you've got the file from the group chat.
Wow. Bye.
Peace.
Bye.
Thank you. Did you get it, Ben? Okay, I'll see you later.
All right, thank you.
Take it easy, buddy.